All right, we're going to work on some examples dealing with exponential functions. So we learned last time that exponential functions really were just functions that had the variable in the exponent spot, like in this one, the x is raised. That makes this an exponential. If I wanted to graph that, I could just plug in different values of x and plug them in here. And so in our homework, we were asked to do that first, just to kind of plug them in to get used to plugging in. But if I wanted to graph one, it would actually have us do one of these numbers, right? So I'm going to do one of those and do the math over here. So if I look at this, if I wanted to graph this thing, I would say g of, let's just choose 1, which would be 2/5 to the first. And then let's do 2, see what it does. So I'm just changing the value of x, 1, 2, 3, making it like that, right? G of 3 would be 2/5 to the third. Let's do g of 0, see what that does. Actually, I'm going to start there, because what is anything raised to the 0 power? It's 1. So I see that one point is 0, 1. So I can plot that point right there. All right. Alternatively, I could have put in a 0, 1 here and hit plot point, and it puts it in there. Let me go up here and do this one. So here, this is going to be, when I do this math, 2/5 to the first power, or just 2/5. So my point will be 1 2/5. So 1 2/5. Plot that point. Right, you with me? Right there. Now let's do 2. Let's go back over here. And this is going to be 2 to the second power, 5 to the second power, which is 4/25. So that's going to be a point. Let me do this one while I'm at it. This is going to be 2 to the third, 5 to the third. That's going to be 8 to the 1/25th. Let me plot those points. Let's do this one first. Right here. This is 2 4/25. So let's do 2 4/25. Plot that point. Then let's do another one. 3 8 1/25. 3 8 1/25. Plot that point. All right. So if you do that, you'll get to some point where you'll have a pattern going, and then you want to just go ahead and plot this point. Oh, you need 5 points in order to do it. So let's do g of -1. That is 2/5 to the -1. So if I do that, wait, that is 2 to the -1 all over 5 to the -1. But when I have negative exponents, that means things flip. The 2 to the 1 will go on the bottom, 5 to the 1 will go up top, which is really just 5/2. So my point would be -1 5/2. Let me plug that in there. -1 5/2. At that point. Now let's see if it allows me to apply the curve to it. Let me punch in this curve, and it does it. Let me check that to see if that's good. And it looks like we're good. All right. Let me take a look at number 4. This is asking us to graph it. Oh, it's already been graphed. I want to know what the domain and range is. The horizontal asymptote, that word asymptote just means it's where it's never going to touch. You see this dotted line? That means it will never touch it. It gets real close, but it never touches it. So what will the domain of this thing be? How far to the left and right will it be? Well, for the domain, it's going to go all the way to the left and all the way to the right, so it's going to be the all reals. For the range, we're looking at y values, right? So all of my y values look like as high as it's going to go will be -2. As low as it's going to go to infinity. So I'm looking at all of my y values less than -2. Y is less than -2. It's not going to include -2 because it never touches it. So let's just check that, and we should be good. All right, here we go.